Hello everyone, we have question 3 here on paper 1 from 2023 and we have a vectors question. So it says relative to a fixed origin O, the point A has position vector 5i add 3j plus 2k and the point B has position vector 2i add 4j add ak, where a is a positive integer. Show that the magnitude of the position vector from O to A is root 38. I've just represented it here on a little sketch. I don't think I necessarily needed to do that for this question. So part A, the magnitude of OA, the magnitude, this is like Pythagoras applied in 3 dimensions. So we square the I component, the j component and the k component, add them together and square root it. And that gives us 5 squared add 3 squared add 2 squared, which is root 38 as required. Now part B, it says find the smallest value of A for which the magnitude of O to B is greater than the magnitude of O to A. Notice it says in the question that A is an integer. Okay, so let's bear that in mind. So what I've done to approach this is I imagined to myself, what would be the value of A if OA was equal to OB? So I thought that would be a good starting point. So if that was the case, we would have 38, because remember, it's going to be, I've squared both sides actually, I should say that. Let's do this here without the, there we go. So OA is root 38 and OB is the root of 2 squared add 4 squared add a squared. So I've then collected like terms and squared both sides. So we now have 38 is equal to 20 add a squared. So take 20 off both sides, 18 is a squared. So a is root 18, so a is 3 root 2. Now, 3 root 2, so let's think about that. 3 root 2 is bigger than 4, so therefore the smallest integer, a value of a, for which it's going to be the case that OB is bigger than OA is going to be when a is equal to 5, okay? And we can test that because when a is 5, we're going to have 20 add 25, which is root 45, and root 45 is bigger than root 38. So the answer for that one is that a is 5. So a nice little, quite straightforward vector question there for question 3. Hope you found that helpful and I'll see you in the next video.